The Udaloy arrived on the carrier group's southern bearing at 7:22 on a Wednesday morning and announced its presence in the specific way that Russian surface combatants announce things in the Mediterranean, with smoke. Not a dramatic quantity of smoke, not a son, one were and your anasa tower, a hackend, this set chamber air and near our Assagiritsi are its emergency calls, but the persistent, faintly brownish exhaust trail that the Sovremeni and Udaloy-class vessels have been producing since the 1980s from their COGOG gas turbine plants, when the engineering spaces are not running at peak efficiency, which, in the case of the ship now bearing down on USS Harry S. Truman's southern flank at 19 knots, was a condition that appeared to be permanent rather than transitional. The moke trail was visible on the E-2D Hawkeye's radar at 31 miles, before the ship itself resolved as a surface contact on the SPY-1 picture. A navigator on USS Truman's bridge, noting the contact's approach bearing and the faint smear on the horizon that preceded it, told the officer of the watch that identifying a Russian naval vessel by its exhaust signature was, in his professional experience, a more reliable method than waiting for the AIS transponder, which was transmitting technically, but with the intermittent enthusiasm of a system whose antenna cable had probably been repaired with something that was not originally antenna cable. The Udaloy-class destroyer Severomorsk, hull number 619, had been operating in the Mediterranean for 3 weeks as part of the Black Sea Fleet's rotational presence commitment, a mission that the Russian Navy describes as demonstrating strategic reach, and that everyone who has watched a Udaloy operate in the Mediterranean for 3 weeks describes as demonstrating strategic persistence despite maintenance challenges that would ground a less determined institution. The Udaloy is not a bad ship. It entered Soviet service in 1980 as a dedicated anti-submarine warfare platform. 8 torpedo tubes, 2 RBU 6000 anti-submarine rocket launchers, 2 Ka-27 Helix helicopters in the flight deck hangar, and a sensor suite that, in 1980, represented a serious Soviet investment in the ASW problem. The ship was built to find and engage U.S. Navy nuclear submarines, and in 1980 it was a credible tool for that mission. In the current year, the Udaloy's mission in the eastern Mediterranean was to follow USS Harry S. Truman's carrier strike group, match its course changes, and be visibly present in a way that complicated the carrier's operational picture, just enough to be worth noting in the daily intelligence summary. The Udaloy was good at being present. Presence was, given the maintenance state of the rest of its operational profile, arguably its strongest current capability. USS Harry S. Truman had been operating in the eastern Mediterranean for 22 days, conducting the combination of presence operations, exercise participation, and air wing sustainment that carrier deployments in this theater have looked like since the Cold War, with periodic adjustments for the current geopolitical landscape, which was providing more material for the daily intelligence summary than the operations staff found entirely convenient. The carrier's flight deck at 7:22 was in the middle of the morning's first launch cycle. 4 FA-18Es and 2 EA-18G Growlers on the catapults for a strike package exercise with NATO partners, the flight deck crew moving with the focused efficiency of people who have rehearsed this sequence enough times that the choreography is automatic. The smell of jet exhaust, hydraulic fluid, and the specific metallic undertone of a catapult track that has been cycling since dawn was the background condition of every morning aboard, as familiar as the ship's motion, and about as noticeable to anyone who had been aboard more than a week. The recovery cycle was scheduled to begin at 11:30. The carrier's standard recovery protocol requires a specific course and speed. The ship turns into the wind at a precise angle relative to the recovery axis, maintains a wind over deck speed that the recovery brief specifies to the nearest knot, and holds this configuration for the duration of the recovery, typically 40 to 60 minutes, depending on the cycle size. During recovery, the carrier's ability to maneuver aggressively is constrained by the fundamental aerodynamics of putting aircraft back on a moving flight deck. Every degree of unplanned course change, every speed variation, every roll induced by an aggressive maneuver becomes a factor in the landing geometry that the landing signal officers are managing. The carrier does not stop flying to maneuver. It maneuvers within the envelope that continued flight operations permit. This envelope is well understood by everyone who operates near carriers. It was demonstrably also well understood by the officer on the bridge of the Udaloy who had been watching Truman's track since 7:22 and had timed the approach to arrive in the carrier's immediate operating area, approximately 40 minutes before the scheduled recovery window began. This was not coincidence. This was navigation. At 10:47, with the recovery window 43 minutes away and the Udaloy now positioned 14 nautical miles on Truman's port quarter and closing at a steady 12 knots, the flag watch officer aboard USS Truman noted the contact's geometry against the recovery track and produced a number that he wrote in the margin of his watch log with the pen pressure of someone who finds the number professionally interesting. At its current closure rate and bearing, the Udaloy would be inside the carrier's maneuvering operating area. The zone within which the carrier's recovery course and speed commitment created a constraint on aggressive course changes. At approximately 11:15, 15 minutes before the first aircraft in the recovery cycle crossed the outer marker, the carrier would be committed to its recovery course. The Udaloy would be close. How close depended on the Udaloy's intentions, which the flag watch officer assessed with the careful language of someone who had watched Russian shadowers before and had developed a working model of their operating patterns. Russian surface shadowers in the Mediterranean operate within a framework that is aggressive by NATO standards and routine by Russian ones. The game, as experienced carrier group officers understand it, is geometry. The shadower positions itself to complicate the carrier's operational picture. Force course changes that cost the air wing launch and recovery efficiency. Generate intercept reports that demonstrate Russian proximity to U.S. naval assets, and collect whatever the ship's sensors can gather about the carrier's emissions and operating patterns. The carrier's response is to conduct its mission regardless. Document the shadower's behavior. Collect whatever the shadower's emissions offer, and avoid the kind of aggressive countermaneuver that gives the shadower exactly the footage of American warship responding to Russian presence that the whole enterprise is designed to generate. It is, in the technical vocabulary of competitive maritime operations, a professional inconvenience managed by professionals who find it more annoying than threatening and more useful than pointless. The Udaloy was doing its job. USS Truman's watch team was doing theirs. The vulnerability here is specific and honest. It is not a kinetic vulnerability. The Udaloy in its current maintenance state, with its gas turbine plant running visibly rough, with the intermittent AIS transponder, with the Ka-27 Helix helicopter that the watch team had observed parked on the flight deck for 48 hours, without appearing to conduct any flight operations, suggesting either a maintenance hold or a condition that the Russian flight deck crew had assessed as requiring time before the next sortie. Was not, by any reasonable threat calculation, a kinetic problem for the carrier group. The Udaloy carries SS-N-14 anti-submarine missiles and various gun systems that USS Truman's defensive architecture would find trivially manageable. The kinetic threat picture was not the concern. The operational vulnerability was this. The Udaloy's positioning, if it placed the ship inside the carrier's 5 nautical mile operating area during the recovery window, would require the recovery officer to account for the contact in the recovery geometry. Not dramatically, the carrier does not stop flying because a Russian destroyer is nearby, but a surface contact inside 5 miles on the landing axis bearing requires acknowledgement in the recovery brief, affects the wave-off procedure, options for aircraft, with emergencies, and creates a documentation obligation that the operations officer would rather not be managing simultaneously with a full recovery cycle. At 14 miles and closing at 12 knots, the Udaloy was 43 minutes from the 5-mile threshold. The recovery window opened in 43 minutes. The numbers were exactly as convenient for the Udaloy as inconvenient for the carrier. The commanding officer of USS Truman made the adjustment at 10:53, not a course change that abandoned the recovery track. The wind geometry did not permit abandoning the recovery track without affecting the air wing's ability to recover its aircraft safely. An acceleration. Truman increased to 26 knots, advancing the recovery window by 18 minutes and putting the first aircraft over the outer marker at 11:12 rather than 11:30. The Udaloy, maintaining 12 knots on its current approach, would reach the 5-mile threshold at approximately 11:47. 25 minutes after the last aircraft in the recovery cycle would have trapped. The recovery would be complete. The constraint window would be closed. The Udaloy would arrive at the close approach geometry it had been navigating toward and find the carrier in standard post-recovery transit configuration, operating at 30 knots and capable of whatever course changes the tactical picture required. The Udaloy's navigation had been competent. The carrier's response had been 1 knot adjustment that cost nothing and gained 18 minutes of operational freedom. The flagwatch officer noted the acceleration in his log and noted its effect on the Udaloy's arrival geometry, with the specific dry satisfaction of someone whose arithmetic had produced the right answer and who was now watching it confirmed by the operations picture. He said nothing to anyone about it. There was nothing to say. It was good seamanship. Good seamanship does not require announcement. Now the intelligence picture, because the Udaloy had been emitting since 7:22, and the SLQ-32 had been collecting since approximately 7:23. And this channel covers what that collection produced in the detail it deserves. The Udaloy's plate, steer fire control radar, the system associated with the ship's SAN-9 surface-to-air missile battery, had been intermittently active since the ship's arrival on bearing. Not continuously active in the way a ship preparing an engagement would run its fire control radar, but cycling on and off in the pattern associated with radar maintenance and operator training. A few minutes of active operation, a shutdown, a restart, repeat. This pattern told the SLQ-32 something immediately useful. The plate steer's cycle intervals were longer than the documented nominal for this system, and the frequency agility sequence during active operation showed 3 transition signatures that did not match the current library entry. The system was performing differently from its documented specification in ways that were characteristic of a radar that had been maintained with substitute components. Specifically, the timing circuits associated with the frequency agility function were showing a drift pattern consistent with capacitor aging in the modulator assembly. This is the kind of finding that sounds narrow and becomes important. A radar whose timing circuits are drifting shows predictable performance degradation in specific engagement geometries, and that degradation is now characterized in the threat library rather than estimated from the nominal spec. The sonar suite, the MGK-335 Orlan hull-mounted sonar that is the Udaloy's primary ASW sensor, had been active in passive mode since 7:30. The SLQ-32 does not directly intercept hull-mounted sonar transmissions, but the ship's sonar processing and data distribution systems produce ancillary electronic emissions that the collection suite catalogs as secondary indicators of active sonar operation. These emissions had been running continuously, which told the intelligence cell that the Udaloy's crew was actively pursuing their ASW mission, looking for U.S. Navy submarines in the carrier group's vicinity, with the dedicated attention that a well-trained ASW crew applies to an environment where a nuclear submarine might plausibly be operating. They were correct that nuclear submarines were plausibly operating nearby. They had not found any. Whether they would have found any was a question whose answer is classified and will remain so. But the collection team noted the sonar processing emissions, logged the active periods, and added them to the profile of the Udaloy's operational ASW behavior that the fleet ASW intelligence staff maintained for future reference. The helicopter, the Ka-27 Helix, parked on the flight deck for 48 hours, finally launched at 12:41, approximately an hour after the carrier's recovery cycle had completed and 50 minutes after the Udaloy reached its closest approach to the carrier group. The Ka-27 conducted 2 transit legs across the carrier group's operating area at low altitude before returning to the Udaloy's flight deck at 14:03. During those transit legs, the aircraft's dipping sonar equipment produced emissions that the collection suite characterized against the existing library. The Ka-27's octopus dipping sonar, the system designed to be lowered into the water on a cable for passive and active acoustic search, was emitting in a test mode during the transit rather than an operational mode, which indicated either a maintenance verification flight or a crew proficiency check rather than an active ASW search. Either interpretation was documented in the collection log. The Ka-27's radar altimeter was also running throughout the transit, and its specific frequency characteristics matched the library entry for the later production variant of the DISS-32 system, a match that the collection team noted as consistent with the ship's reported refit schedule and useful for confirming the refit's actual completion status against the reported one. The communications picture was, by the standards of Russian naval operations, relatively disciplined. The Udaloy's encrypted primary communications ran on the standard Russian naval HF architecture, with the metadata providing transit timing and traffic volume data without content access. Two secondary exchanges were partially accessible: a routine position report to the Black Sea Fleet Operations Center, transmitted in the clear due to a procedural lapse that lasted approximately 4 minutes before someone corrected it, and an internal communications exchange between the bridge and engineering spaces that the EW operator characterized as consistent with a recurring engineering consultation about the starboard gas turbine's performance. The position report provided a precise navigation fix that confirmed the ship's track geometry and validated the collection team's bearing and range model. The engineering exchange added a specific data point to the Udaloy's maintenance profile. The starboard turbine was running at reduced power output, which was consistent with the visible exhaust signature and which explained the ship's maximum demonstrated speed of 19 knots, below the class's documented capability by approximately 7 knots. The Udaloy had approached the carrier group at its best available speed. Its best available speed was 19 knots. The electronic warfare officer aboard USS Truman presented his initial collection summary to the strike group intelligence officer at 15:30. The summary covered the plate steer timing circuit drift characterization, the sonar processing emission profile, the Ka-27 system configuration confirmation, and the engineering communication intercept. The strike group intelligence officer read the plate steer section with the focused attention of someone who has been waiting for a specific piece of data and has just received it. Then asked 2 questions about the timing circuit characterization that indicated he understood its operational significance. The EW officer answered both questions. The intelligence officer approved the distribution to 6th Fleet and to the Naval Electronic Warfare Intelligence Center without modification, and with a priority designation that moved it to the front of the processing queue. The Udaloy had spent 7 hours in the carrier group's operational area. It had provided 7 hours of collection. The money accounting for this operation has a specific structure that rewards attention. The Udaloy's operating cost for a day's shadow operation in the Eastern Mediterranean, fuel for the gas turbine plant at its current reduced efficiency operating state, crew operational pay, the overhead of a ship that has been deployed from Severomorsk to the Mediterranean and back on a rotational cycle, runs to approximately $180,000 to $220,000 per day in equivalent Western accounting. 3 weeks of deployment with periodic replenishment from the naval logistics chain. Call the total mission cost approximately $4.5 million for the deployment period. The mission objective: maintain presence on the carrier group, complicate its operational picture, collect whatever the ship's sensors can gather, and demonstrate that Russia's Mediterranean commitment is sustained. The Udaloy had been present for 3 weeks. It had complicated the operational picture in the specific way that shadow operations are designed to complicate it, requiring documentation, generating intercept reports, adding a variable to the carrier's planning picture. These are real effects. They have real operational value in Russian doctrine. USS Truman's additional operational cost attributable specifically to the Udaloy's shadow operation on Wednesday. The acceleration to 26 knots and the early recovery window cost approximately $45,000 in additional fuel and operational overhead against the standard transit. Baseline: the intelligence processing for the SLQ-32 collection package, plate steer characterization, sonar emissions profile, Ka-27 system confirmation, engineering communications analysis, added $140,000 in analyst time over 72 hours. Total additional U.S. cost attributable to the Udaloy's Wednesday presence, approximately $185,000. The plate steer. Timing circuit drift characterization alone. The finding that the fire control radar's frequency agility was performing below specification in ways that defined its engagement geometry vulnerability was assessed by the Naval Electronic Warfare Intelligence Center at approximately $2.3 million in collection cost equivalents. This is what it would have cost to achieve equivalent characterization through dedicated collection missions targeting this specific system under controlled conditions. The Udaloy had provided it as a byproduct of operating its radar in maintenance mode within collection range of the SLQ-32 for 7 hours. Nobody aboard the Udaloy sent an invoice. Nobody needed to. The Udaloy's Ka-27 completed its post-transit deck check at 14:45 and was secured in the hangar. It had launched once in 48 hours. The hangar door closed. The smoke trail from the starboard turbine persisted, slightly less brown than the morning's because the engineering spaces had made whatever adjustment the 1241 consultation had recommended. It had not solved the underlying issue, which had the specific character of an issue that a 7-week deployment cycle's maintenance window would also not solve, because solving it required a component that the Severomorsk depot had been waiting for since the previous quarter. The chief engineering petty officer knew this. The turbine knew this. The SLQ-32's engineering emissions log knew this, and had known it since 10:14 that morning. At 1600, the Udaloy altered course to the northeast, away from the carrier group, toward the transit lane that would take it to its next operating position. The shadow phase of Wednesday's operation was complete. The flag watch officer noted the departure bearing and speed, confirmed the clearing geometry, and updated the contact picture with the notation, "Shadow departed, resuming standard transit." He reviewed the morning's log entry one more time. The acceleration to 26 knots. The early recovery. The Udaloy's arrival at the close approach geometry 25 minutes after the last trap. He considered writing a note about it and decided against it. The log already said everything it needed to say. The number said the rest. Russian state television's weekly Mediterranean patrol segment aired that evening, as it does weekly during Russian naval deployments in the theater. The footage showed the Udaloy at sea in the eastern Mediterranean, genuinely present, genuinely at sea, genuinely demonstrating the persistence that 3 weeks of Mediterranean deployment requires, regardless of the maintenance state of the starboard gas turbine. A naval spokesperson described the patrol as demonstrating Russia's ability to monitor NATO naval activities and maintain strategic presence in the Mediterranean, noting that Russian naval forces had operated in close proximity to the U.S. carrier group throughout the week. The broadcast was accurate. The proximity had been real. The spokesperson did not specify that the closest approach had occurred 25 minutes after the carrier completed its recovery cycle, or that the timing had been affected by an 18-minute adjustment that cost Truman approximately $45,000 in fuel. The broadcast did not mention the plate steer timing circuit drift. It did not mention the starboard turbine. It did not mention the Ka-27's 48-hour maintenance hold, or the DISS-32 altimeter frequency that confirmed the ship's refit status. It described presence. The presence was real. The rest of the picture was in the SLQ-32 file, which does not broadcast. The flight deck crew secured from the day's final launch cycle at 1940. The smell of the flight deck at day's end, jet exhaust, sea spray, the specific compound of hydraulic fluid and heat that never fully dissipates in the Mediterranean summer, was the same it had been at 7:22 and would be tomorrow and the day after. The Udaloy was 17 miles northeast and opening at 12 knots, the starboard turbine producing its characteristic exhaust. The crew standing their watches in the specific routine of a ship that has been at sea long enough to be past the interesting part of the deployment and into the part where doing the job well is the only available form of novelty. They had done their job. They had been present. They had complicated the carrier's Wednesday. They had contributed 7 hours of their radar's emissions to a collection package that was going to be read with interest in Washington. Neither contribution cancels the other. Both are the job. The sea does not adjudicate between them. It is simply there, the same water, the same depth, the same indifferent surface that carries the Udaloy's smoke and the Truman's wake with complete impartiality. as it has carried every ship that has ever presumed to contest it. Bye for now.